Hey everyone, ready to dive into the world of engineering? Let's get started. In this video, we're diving into the fascinating world of circuit design and its crucial role in electronics. You'll learn the fundamental concepts that underpin circuit design, including the components involved and how they work together to create functional devices. Understanding circuit design is essential as it forms the backbone of everyday technology, from smartphones to home appliances. By grasping these principles, you'll gain insight into how these devices operate and how they can be improved. We'll also explore practical applications of circuit design, showcasing how it impacts various industries, including automotive, healthcare, and consumer electronics. Whether you're a budding engineer or simply curious about the technology around you, this video will equip you with valuable knowledge that enhances your appreciation of the devices you use daily. So let's get started on this electrifying journey, understanding basic components. In this segment, we'll explore the fundamental components that form the building blocks of circuit design: resistors, capacitors, and inductors. Resistors are crucial for controlling the flow of electric current, ensuring that components receive the appropriate voltage. Capacitors, on the other hand, store and release electrical energy, playing a vital role in smoothing out voltage fluctuations. Inductors are used to store energy in a magnetic field, which is essential for filtering and tuning applications. To help visualize these concepts, we'll use diagrams and animations that illustrate how these components interact within a circuit. By understanding how resistors, capacitors, and inductors work together, you'll gain a clearer picture of how circuits function as a whole. This foundational knowledge is key to mastering more complex circuit designs in the future. Let's dive deeper into each component and see them in action. Circuit diagrams and symbols. In this section, we'll focus on how to read and create circuit diagrams, which are essential for visualizing electronic circuits. First, we'll introduce you to the standard symbols used in these diagrams, such as the symbols for resistors, capacitors, and power sources. Understanding these symbols is crucial for interpreting circuit designs accurately. Next, we'll demonstrate how to sketch simple circuit layouts, guiding you through the process step by step. You'll learn how to arrange components logically and connect them with lines that represent electrical pathways. Clear and precise diagrams are vital for effective communication among engineers and technicians, as they ensure everyone understands the intended design. By mastering circuit diagrams, you'll enhance your ability to collaborate on projects and troubleshoot issues efficiently. Let's get started on creating your own circuit diagrams. Ohm's law and circuit analysis. In this section, we'll introduce you to Ohm's law, a fundamental principle in circuit analysis that describes the relationship between voltage, current, and resistance. According to Ohm's law, the voltage across a conductor is equal to the current I flowing through it, multiplied by the resistance, R, of the conductor. This is expressed as VIXR. We'll provide practical examples of calculations using this law, such as determining the current flowing through a resistor when a specific voltage is applied. Additionally, we'll discuss how to analyze simple circuits using Ohm's law, enabling you to solve for unknown values and understand circuit behavior. By mastering this essential concept, you'll be better equipped to tackle more complex circuit designs and troubleshooting scenarios. Let's dive into the world of Ohm's law and see how it applies to real-world circuits. Building a simple circuit. In this section, we'll guide you through the exciting process of building a basic circuit. First, let's list the materials you'll need for this simple project: a breadboard, a battery, a resistor, an LED, and connecting wires. With these components in hand, we can start assembling our circuit. Begin by placing the LED on the breadboard, ensuring the longer leg anode is connected to the positive side. Next, connect the resistor to the shorter leg cathode of the LED and then link it to the negative side of the battery. Finally, connect the battery to the breadboard and watch your LED light up. We encourage you to experiment with different configurations, such as changing resistor values or adding more LEDs. This hands-on experience will deepen your understanding of circuit design and inspire your creativity. Troubleshooting common issues. In this section, we'll discuss common problems encountered in circuit design and how to effectively solve them. One frequent issue is short circuits, which occur when unintended connections create a path for current to flow, potentially damaging components. Another common problem is component failures, often due to incorrect voltage or overheating. To diagnose these issues, start by visually inspecting your circuit for loose connections or damaged components. Use a multimeter to check for continuity and measure voltage levels at various points in the circuit. If you identify a faulty component, replace it and test the circuit again. Remember, troubleshooting is a valuable learning experience. Embrace mistakes as opportunities to improve your skills and understanding of circuit design. By learning from these challenges, you'll become a more proficient designer and problem solver. In this video, we've explored the essential aspects of circuit design, emphasizing the importance of understanding its basics. We discussed fundamental components like resistors, capacitors, and inductors, and how to read and create circuit diagrams. We also introduced Ohm's law and its application in circuit analysis, guiding you through building a simple circuit and troubleshooting common issues. That's all for today. Tech Blueprint for more clear and practical engineering content.